of the things that we talked about early in this chapter is just because you get to have a bigger molecule, just apply the same rules. Don't stress or worry about it being overly complicated. We're just going to apply the same simple rules that we've been learning to just a bigger molecule. So we're going to draw the molecule called acetone, which they tell us here is CH32CO. So again, if we kind of break this apart, we're going to have CH3CO, CH3. That's what it's kind of telling us here, is we've got a carbon oxygen that has two CH3 groups. I'm just kind of breaking this apart so we can see the total number of atoms that we have, so we can see the glue that we need to put together. 3 carbon atoms, which means we're going to have 12 electrons from there. 6 hydrogen atoms, 6 electrons, and then 1 oxygen, another 6 electrons. So 24 electrons to glue this molecule together. Carbons are going to tend to be in the middle, so I'm going to put these in together. And the way this is drawn here, I know that I've got my oxygen connected there, and then I've got hydrogens attached on these 3. So what we're drawing right now is an organic chemistry molecule. Organic chemistry is chemistry based on carbon, and so this is one of those molecules that you'll see in organic chemistry. But we can see that they already gave us some information that we had a carbon bonded to 3 hydrogens, and 2 of them were attached to a carbon bonded to an oxygen. So if we go ahead and connect things together here, 2, 4, 6, 8, 10, 12, 14, 16, 18. So 18 electrons. We've got 6 electrons left. 2, 4, and I've been through this before. I could put those 2 electrons up there, but then I've got carbon without a complete octet, and then I've got a formal charge that I'd have of -1 on my oxygen. I know how oxygen likes to bond. 2 bonds and 2 lone pairs. And that makes carbon happy too by giving it a complete octet. So this guy's good to go. So once we have a proper Lewis structure, now we can go ahead and determine the shape around each central atom. So this is where we're kind of doing something new here, is recognizing that there's 3 central atoms. So each of these has the potential to have a shape around it. So A is going to be actually equal to C because there's symmetry in this molecule. So we're going to have the same shape around each of those CH3 groups. And we can see that the magic number is 4. We can count 4 things around this central atom. Happens to be 4 atoms, so the shape is tetrahedral. Tetrahedral, and then the bond angles are going to be 109.5 degrees. I keep writing degrees C. Sorry for that. 109.5 degrees. Now, for our B case, we can see that the magic number is going to be 3. We've got 3 things that we've got surrounded there. Those 3 things also happen to be 3 atoms, so in that case we have trigonal planar as well for this carbon atom. So again, 3 things being trigonal planar. Oftentimes, what we'll see with carbon atoms, because carbon doesn't like to have any lone pairs around it, what we're going to see is that whatever we figure out for the electron group arrangement, that's also going to be the molecular group arrangement and the molecular shape.